Welcome back. We will be looking at big data analytics now, the analytics aspect. Okay, fine, you can collect the data. How exactly does the analytics work? It's a fairly straightforward concept, but not the software side. The software side, the actual work is quite complicated and requires a lot of coding. But to understand what exactly is going on and what we will be looking for and what we are trying to do, that's a fairly straightforward discussion here. First of all, data analytics is the process of collecting, organizing, and analyzing large sets of data, big data in this matter, to discover patterns and other information which an organization can use for future decisions. So it's collecting, organizing, and analyzing. Collection of data is essentially just getting access to data as much as possible with permission, if possible. Organizing is that the data that you've collected is stored in a way that has some kind of system to it, rather than just abruptly and without any pattern or without any kind of discipline. Rather than storing it that way, having some sort of basic discipline, at least you at least you have different headings for each of the data points that you maintain, or you store the data based on the date and the time. There is some sort of arrangement to the data. um, Especially it can be used in data warehouses in a database format. And finally, the analysis aspect, we briefly touched on it in the data warehouse, where we talked about associations, sequences, etc. So patterns. What happens is data mining software is used to go through that data, to sort and sift and analyze that data, to look through that data for specific behaviors that we are looking for. We call them correlations and patterns. So a good example is Google Analytics, which a lot of organizations are using, especially online, with website traffic and all of that. So there's a lot of information that the analytics, by region, by device, etc., that the website or Google Analytics will provide to you. Where in the location in the search index, everything, SEO related data, search engine optimization related data. So a lot of information is provided to you that you can use through data mining software. Now, one of the components that makes this process of data mining easy is data visualization. Data visualization is the graphical presentation. It allows a large volumes of complex data to be displayed in a visually appealing and accessible way that facilitates the understanding and the use of the underlying data. Because just imagine an Excel sheet with a lot of numbers versus a pie chart and a few graphs. So the graphs are the much better and the more preferred approach, because you can actually make sense of all that data. Now, of course, someone who is more Excel capable and who is who prefers that kind of information, yes, but not all kinds of business leaders are like that, and they also don't have the time. So data visualization is a big part of DSS, decision support systems, because finally, once you've mined the data and you've extracted the patterns, if you can visualize it, then the decision making process becomes even easier. um, Usually companies build what we call dashboards. And what happens with a dashboard is that in a dashboard you have all the standard KPI measurements, all the pie charts and the line charts and the bar charts and everything, all the visualizations put into one format, right? One page or one view. It can be several components, several sectors, profitability, whatever, profitability, liquidity, something like that, or product based. But you basically have all the metrics in one location, visually presented, and you call it a dashboard. So you can go through the illustrations. Fine. Now, the other component that is important for you to understand is data analysis methods. That is something that is important for the APM exam, because you have to understand what kind of approaches may be suitable in a scenario. So, in a scenario where predictive analysis is required, if you're going to do descriptive analytics, then it's not really going to match, because those two have fundamentally a big difference between predictive being futuristic and descriptive being backward looking. So then you have to be able to critically look at the situation and say, look, what they're doing is wrong. We may need to go for a predictive approach here. So that is the kind of questioning that mostly can appear in the APM exam. So you need to have understanding of the four approaches to data analysis and how they work basically. There are four. descriptive, diagnostic, predictive, and prescriptive. And the best way to understand it is by looking at the sub questions that they answer. Descriptive is what has happened, right? What has happened, looking backward basically. Descriptive analytics is looking at what has happened. Diagnostic analytics is why did it happen, identifying the root cause. Predictive analytics is what will happen next, future. So what is going to happen next? And you have to use your diagnostic and descriptive in order to do predictive analytics. You cannot do predictive analytics like I don't know, like out of your head or something like that. You have to base it on your descriptive and your diagnostic. And prescriptive is what action should be taken, right? What are your next steps? What are you going to do? Predictive is what will happen next, that's out of your control. Prescriptive is what are you going to do, that is within your control. So moving from left to right, complexity and effort increases, but added value also keeps on increasing. You basically have a basic description and each of the advantages and disadvantages of descriptive and diagnostic, um, predictive and prescriptive listed here in the illustrative table, which you can take a look at. The points are fairly straightforward. It's all is surrounding the main four questions: why, what has happened, why did it happen, what will happen next, and what are we going to do about it? What action are we going to take? So what do you think is the most important? Yes, the most important would be prescriptive because it's about your future decisions, and that's the most important thing in a business. That's what you're doing. That's what you're doing on a daily basis. But it may be most dependent on descriptive and diagnostics. And if you have good information, your quality of descriptive and diagnostic analysis is high, the veracity is also high, then your prescriptive and even predictive analytics is going to be very strong. So there are different tools, different approaches, different sub softwares that are being used under each of those four approaches or four methods. Um, so a few examples of prescriptive analytics is, I think the best example is Google Maps, your optimal route. So it's about what you should do next. So what Google Maps does is it considers all of the present current traffic information and the past traffic information, all the people who've taken that route, and it suggests what you should do next. So you do it. And most of the time, if you're using Google Maps, you're going to take that route unless you are very familiar with the road, at which point you realize what you know is better than Google Maps in any case, at least in some cases. Um, Healthcare, improves patient care by evaluating factors such as rates of readmission and cost effectiveness of procedures, etc. Insurance companies actually use predictive analytics based on historical data, based on your behaviors, based on all the consumer behaviors, and what kind of history in terms of charging. The premium can get actually lower if you are if you're maintaining your health better, and your records show that your health is optimal, and you do regular maintenance, your body, and you do regular checkups, etc. So at different points, different types of analytics is used. I think we are mostly used to descriptive and diagnostic analysis. That's what we are used to. You need advanced software to do predictive analytics, and of course you can use your mind and you can make a general projection. I think climate and weather, I mean North America where I reside, Canada, we are in the winter season, and it's really amazing. In fact, sometimes at least a good 60-70% of the time the weather forecast is accurate. So it's not perfect, it's absolutely not perfect, but the general forecast is relatively accurate, at least good 60% of the time, which is remarkable, right? Which has allowed a lot of people to plan their lives and make things easier in their life. So this is basically descriptive and diagnostic analysis being used for predictive and prescriptive analytics. Now, in each of these techniques, you have already learned in PM different approaches like linear regression, which we looked at as a forecasting, because forecasting, see, Forecasting means predictive and prescriptive analytics. It's forecasting your future. So if we consider it as a predictive analysis, as to what can happen, what would happen before you decide what are you going to do, because you will decide your prescription, or you will decide your action based on what you think is going to happen. So linear regression, using this formula, which you can fully automate using a computer software, decision trees in terms of probability theory, where you're looking at, if this happens, that will happen. If this happens, so for example, here, size of the investment, you can either go for full scale or partial. And under those two conditions, the economic conditions may be good or poor, good or poor. So it's essentially, different decision tables, right? So you have four outcomes, four possible outcomes, and you get all the outcomes, and you can use minimax, maximax, depending on your risk appetite. You can decide, this is what I'm going to do, or this is how I'm going to deal with it. You have all these methods, right, which are built on looking at the past, so that a predictive analytic can be made. All of these methods, even Monte Carlo simulation, which is essentially, now what happens with regression and all of that is that the data points are limited, right? But what with Monte Carlo simulation, it's actually a method of sensitivity analysis, where the classical sensitivity analysis you learn in P4 is isolating one variable and seeing, if one variable changes, how will the outcome get affected. Monte Carlo, in fact, I think there's a Monte Carlo add-in you can incorporate into your MS Excel as well, is basically you can actually get results to see multiple variables, how exactly many variables work. So that's how Monte Carlo simulation works. And it'll give you these kind of projections, these kind of graphics, instead of giving 1 point or 2 point, this or that, like expected value, how EV works. It gives you all kinds of possibilities, and in this graph, it's the potential returns at potential profit levels, and the frequency mapped. Basically, it's the number of outcomes, right? The different possible outcomes mapped for every point, right, in a continuous format. And you basically are trying to decide what to do. So this is predictive analytics based on descriptive and diagnostic analytics. And finally, you look at the result and you'll try to decide, okay, am I going to invest in project A or B? There is no right answer. Even to this question, there is no right answer. You know that project B has the higher average profit, uh, more than project A, but you do know that project A actually has a higher frequency. So the number of times you can make the profit is high. The assurance with the profit is low, because you never know what will happen. So it really depends on your risk appetite. If you are a more risky person, then even though the frequency of the profits are low, that the number of times you make the profit is low, you might actually go and take a chance and think, okay, I'm positive that this might work. Risk taking attitude. But if not, you'd rather make a lower profit but a higher number of times and be assured that you're going to gain something, and choose project A. So the decision making is like that. So just go through these few examples where they've illustrated the use, but again, I want to remind you, calculations are not required. Of course, with Monte Carlo, there's no calculation. You need a software for this. But decision trees and regression, again, calculations are not required. They might have done it. And it could be from a budgeting perspective. It could be from a perspective of just contemplating and evaluating and saying, this is a point where descriptive and diagnostic analysis is being used, so that future predictions can be made, and ultimately prescriptive analytics to see what are we going to do. So that kind of understanding is what you need to build as far as these are concerned. Um, Finally, with respect to data analytics, what we need to understand is that beyond all of this, with modern information technology age, the digital age, digital, I think 4.0, there are new versions and new types of analytics that are being invented on a daily basis. So The ones we've looked at, they use data in a variety of different structured and unstructured forms, that is text, images, video, and voice. But nowadays, what is happening is that there are advanced analytics that are happening purely focusing on each of these different components: text analytics, image analytics, video analytics, and voice analytics. So I can give you a few examples. Text analytics, Twitter, that uses text analytic application, for example, on customer short written feedback questions or other comments to identify any issues or opportunities. So I think recently, like Twitter has this automatic way of deleting racial abuse related tweets, right? That is text analytics being used for predictive and prescriptive purposes by the software in a machine intelligence based environment, where the AI will track using text analytics every tweet. Millions, if not billions, of tweets are getting tweeted, right, every day. So it's a massive volume of big data that's being on a real time basis analyzed. And depending on certain keywords that they've flagged, if those words appear in a tweet, they will delete the tweet. Of course, I think Elon Musk is getting rid of all of those. Image analytics, I think one good example I can tell you is that if you post any image on major softwares like Facebook, Instagram, there is a embedded caption to that image. And the image, if you post your picture with your pet, you will see an automatic description of that picture nowadays, saying a young male with a dog or something like that. So this is image analytics being used to get a description of the photo. It helps other purposes, serves other purposes, great many purposes that we know and more purposes that we don't know, like Google search. It that caption gets fed into Google search, that when you do Google search for something related to that photo may appear. Video analytics, I think it's one good example is when you're subtitles. So video analytics is now huge, and the audio of the video is now analyzed to the level that subtitles are fully automated. At least it's 85%, 90% accurate at that. That's a remarkable achievement. This is a video, someone speaking. There are AI and machine learning softwares that can now basically do analyze that video, analyze what the video is mentioning, talking, and convert it entirely to subtitles. So this is, and captions. This is a great achievement of video analytics. You can actually read other things as well here. Voice analytics is software that is being used automatically to identify and analyze speech, like words and phrases. I think one of the best examples is Shazam, the mobile app, which can listen to various tunes maybe in the background or something, recognize that tune. Even you can hum a tune, and it'll recognize what the song is, and it'll tell you what that particular song is, from where you got it. So this is audio analytics, and being used effectively. Voice analytics being used. So I think subtitles was another example. Captioning, all kinds of technologies are being used here. We have, yeah. So I think Alexa and Siri in Apple. All of those are good softwares that have advanced voice analytics that recognizes your speech, recognizes what you're saying, recognizes who you are, and does what you want them to do. This is amazing. So these are all different alternate analytics software and analytics capabilities that are now developed and embedded. And one last point is sentiment analysis, that is opinion mining. So this is a big deal. It's on YouTube. It's on, especially on social media. It's huge on TikTok, etc. It is the process of determining the emotional tone behind a series of words to gain understanding of attitudes, opinions, and emotions. Imagine a company which can do this. How much of insight are they gaining about the human? How much learnings, right? They're basically trying to decode it. And all of this is being done in the name of developing and improving AI, because they have to build an algorithm that can determine human emotion. So if they have enough information, if they have 8 billion data points of human emotion, let's say, or no, that might not be enough. But if they have enough complexity, enough volume of different human emotions and the tones, imagine what they could do by embedding it into a AI, an AI robo, which has so much of human information that it will also know what to do in a given situation and what tone to take in a given situation, right? So I don't think we are even close to that, but that's where we're heading. So these are the different types of analytics that are available. So make sure that you do a thorough reading of it and get, especially the illustrations, the examples that are provided. That will give you more insight as to how this works. And we will be moving on to ethical issues in the next segment. Until I see you then, good luck and thank you.